Good morning. During previous live session, we have learned about test of similarity of two triangles. There are three proper tests for similarity of two triangles that I'll revise here again. That is AAA test, that is nothing but AA test. Second one is SAS test, and third one is SSS test. Means if two angles of one triangle are congruent with corresponding two angles of other triangle, then the two triangles are similar by AA test. SS test means if two sides of one triangle are in proportion with corresponding two sides of other triangle and included angles are congruent, then the two triangles are similar by SAS test. And SSS test means if all the three sides of one triangle are in proportion with corresponding three sides of other triangle, then the two triangles are similar by SSS test. We have solved some examples of practice set 1.3 also during previous session, that is we have solved example number 1, 2 and 3. Now we will solve remaining examples of practice set 1.3. We will start with example number 4. Now see what is given in this example. One diagram is given. Look at this example number 4 from practice set 1.3. One diagram is given, that is triangle ABC is given. That is in triangle ABC, AP is perpendicular to BC, BQ is perpendicular to AC. Then B dash P dash C, B dash P dash C means point P is between point B and C. Also A dash Q dash C means point Q is between points A and C. Then prove that triangle CPA, this triangle is similar to triangle CQB. Triangle CQB means we have to prove these two triangles similar. Observe these two triangles, that is CPA, this one. We have to prove this triangle similar with triangle CQB. We have to prove these two triangles similar. Now there nothing about sides is given, only about angles is given, therefore we can't use here SAS test and SSS test also. We can't use these two tests. Some information about sides is given, but that will use afterwards. But while proving these two triangles similar, we will not use these two tests. Therefore we can use AA test by finding out angles or congruent angles between these two triangles. Now first step is to write proper names of these two triangles, and these are the proper name, that is triangle CPA and triangle CQB. That is in triangle CPA and triangle CQB. Now what are congruent parts in these two triangles? That is triangle CPA and CQB. One angle is given, that is 90 degree. Of triangle CPA, angle CPA is 90 degree, and for triangle CPA is 90 degree, and for triangle CQB this angle is also 90 degree, that is angle CQB is 90 degree. Therefore angle CPA is congruent to angle CQB. Reason will be each 90 degree. Angle CPA is congruent to angle CQB. CPA is for this triangle and CQB is for this triangle. Now we want one more pair of angles, but which is not given, but we can find out. Observe this angle. Angle C is common to both angles, means angle C is angle for this triangle also and for this triangle also, but the names are different, but angle is same. Now what will be the name of this angle for this triangle? That is angle PCA. Angle PCA is congruent to angle. Now same angle, by using this triangle, name of this triangle will be QCB. QCB. Reason will be same angle, that is common angle. Common angle between these two triangles. Observe again, this angle is common angle for these two triangles. Observe these triangles again. First one is this triangle and second one is this one. For this triangle, name of this angle is angle PCA, and for this triangle, name of this angle is angle QCB. Same angle but the names are different. Reason will be common angle. Hence, triangle CPA is similar to triangle CQB by angle, that is AA test. Means we have reached up to this target, that is triangle CPA is similar to triangle CQB. Now our next target is to find out AC. Find out AC, that is the side of one of these two triangles. Now since these two triangles are similar by A test, hence their corresponding sides are in proportion. Now by using these names also we can write corresponding sides in proportion, means three ratios will be there. Now first two letters that is CP upon CQ. The next two letters that is PA upon QB, and first and third CA upon CB. But while writing these names or these proportions, these two names should be perfect or correct. Then only we can use the shortcut. Reason will be corresponding sides of similar triangle, that is CSST, corresponding sides of similar triangles. Now out of these three ratios we want only two ratios and we don't want one ratio. Now observe these values which are given. We have AP, means PA is given, BQ is given, this one is given, BC is given, this one is given, and we want AC, means CA. So we don't want this first ratio, therefore we are writing these two ratios again, that is PA upon QB is equal to CA upon CB. Means excluding this part, writing these two ratios again. Now putting values, PA means AP and PA are same, is given as 7. QB means BQ is given as 8. CA, that we have to find, CA is nothing but AC, and CB, that is BC, is given as 12. By cross multiplication we will get 8 into AC is equal to 7 into 12. Therefore we get AC is equal to 7 into 12 by 8. 4 2s are 8, 4 3s are, that is AC is equal to 21 by 2. Therefore we will get AC as 10.5 unit or 10.5 unit. Since unit is not given, I will write only unit. See once again, what is given in this question? This is question and this is answer. Question is already with you in your textbook, only you have to write answer. See what is given in triangle ABC. AP is perpendicular to BC, BQ is also perpendicular to AC, means there are two perpendiculars in this diagram, and we have to prove these two triangles similar, that is triangle CPA and triangle BQC or CQB. Now in these two triangles, these two angles are 90 degree, that is angle CPA is congruent to angle CQB. Reason will be each 90 degree, and this angle is common angle but names are different for both triangles, that is angle PCA, that is this angle C must be in between, and angle QCB, here also C must be in between, which is common angle. Hence triangle CPA is similar to triangle CQB by AA test. Now since these two triangles are similar, therefore their corresponding sides are in proportion. CPA upon CQ is equal to PA upon QB is equal to CA upon CB, corresponding sides of similar triangles. Now out of these three ratios we want only two ratios. Since we don't want this ratio, since nothing is given about CP and CQ, therefore we will not use this one. Therefore writing these two ratios again and putting values, then we will get AC is equal to 10.5, Means we got AC here. Take screenshot of this, then we'll move towards next example, that is example number 5. In example number 5, one trapezium is given. That is PQRS, trapezium PQRS. I am not going to write all this information. I am writing in short. PQ is parallel to SR. PQ is parallel to SR. Then AR is equal to 5 AP. AS is equal to 5 AQ. Then prove that. SR is equal to 5 PQ. SR is equal to 5 PQ. Now see in this example, what is given? Quadrilateral PQRS is a trapezium, is only one pair of opposite sides. Only one pair of opposite sides is parallel, and which is given as PQ and SR. Both are parallel with each other. PQ is parallel to SR. So some relation about sides is given, that is AR. This point is A. AR is 5 times of AP. AR is 5 times of AP. And AS is 5 times of AQ, and we have to prove SR is also 5 times of PQ. Means there is relation between these sides, and we have to find triangles containing these sides, that is SR, triangle containing SR, and triangle containing PQ. Triangle containing side as SR and triangle containing side as PQ, and these two triangles are triangle ASR. This is triangle containing side SR, and triangle APQ. These two triangles. Now we have to prove these two triangles similar, then we will reach up to this target. Now your target is to prove these two triangles similar. First step is to write proper names, that is in triangle. We'll start with this triangle. In triangle PAQ and triangle. In triangle PAQ. Now what will be the name of this triangle? A should be in between. We'll start with RAS, not SAR. We'll start with RAS. Why is it so? That we'll get know afterwards. That is RAS. Now in triangle PAQ and triangle RAS. What about congruent parts? Nothing about sides is given. There is a relation about sides is given, but that will use afterwards. What is given, or what is given indirectly, that is these two angles. What is the type of these two angles? Angle PAQ and angle RAS. These two angles are called vertically opposite angles, and vertically opposite angles are always congruent. Means for this triangle we can write angle PAQ is congruent to angle RAS. Reason will be vertically opposite angles, vertically opposite angles. We want one more pair of congruent angles. Observe these two angles, that is this one and this one. For that, observe this diagram like this. This is PQ and this one is SR, and these two are parallel, and this is a transversal. PQ and SR means these two lines are parallel with each other, and this is a transversal. And if two lines are parallel with each other, then the angles made by transversal or the alternate angles made by transversal are congruent. And this is one of the pairs of alternate angles, that is this one and this one, and same angles are here. That is PQ is parallel to SR and PR is a transversal. Therefore, these two angles are alternate angles. Therefore, these two angles are congruent by alternate angle test that we have learned. You have learned last year. That is angle APQ is congruent to angle ARS. Reason alternate angles. Now two angles are enough. We can write third pair also. We can write this angle is congruent to this angle also. Reason will be same, that is alternate angles. But we don't want. We want only two angles to use A test. Hence triangle PAQ is similar to triangle RAS by angle test, that is A test. But this is not our target. Our target is to show SR is equal to 5PQ. Now, since these two triangles are similar by A test, hence their corresponding sides are in proportion. Now the checks names are correct or wrong. PAQ and RS correct. Angle A is between these two, and P is congruent to R. Therefore, P and R should be the starting points. Now, start names, that is PA upon RA is equal to AQ upon AS is equal to PQ upon RS. Check again. PA upon RA is equal to AQ upon AS is equal to PQ upon RS. Reason will be corresponding sides of similar triangles, that is CSST. Now, suppose this is statement number 1. We'll keep this as it is. Now, move toward this part of this example, that is AR is equal to 5AP and AS is equal to 5AQ. Now, taking this AR that side, we will get 1 is here, that is 1 into AR is there, and taking 5 this side, we will get 1 upon 5 is equal to AP upon AR. Check it again. There is 1 here which is not written. 1 upon 5 is equal to AP upon AR. Similarly, and 1 upon 5 is equal to AQ upon AS. Changing sides, we will get AP upon AR is equal to 1 upon 5 and AQ upon AS is also 1 upon 5. Suppose this is statement number 2, statement number 3. Hence, from 1, 2 and 3, from 1, 2 and 3. Now, say 1, 2 and 3. What is statement number 2? AP upon AR is equal to 1 upon 5. But AP upon AR is also here. PA means AP and RA means AR. Means AP upon AR. This ratio, value of this ratio is 1 upon 5. Names are different, but value is same. PA is nothing but AP. R is nothing but AR. Means AP upon AR is 1 upon 5. Value of this ratio is 1 upon 5. Sorry. Then AQ upon AS is 1 upon 5. AQ upon AS is also 1 upon 5. Means this is 1 upon 5, this is also 1 upon 5, and all these three ratios are equal. Hence PQ upon RS will be also 1 upon 5. PQ upon RS will be also 1 upon 5. Hence from 1, 2 and 3 we can write PQ upon RS is equal to 1 upon 5. From this we will get, by cross multiplication we will get RS into 1, that is RS is equal to 5 into PQ, and RS means SR. SR is equal to 5 PQ. Is proved. See once again, there is one trapezium given, that is quadrilateral PQRS is a trapezium in which PQ is parallel to SR. Opposite sides of one pair is parallel. These two are parallel. Then this relation is given between sides, and we have to prove SR is equal to 5 PQ. And to show this, we have proved these two triangles similar by A test. See, in these two triangles, these two angles are congruent reason vertically opposite angles. These two angles are congruent reason alternate angles. Hence, by A test, these two triangles are similar by A test. Hence, the corresponding sides are in proportion, that is CSCT statement number 1. Now, taking these two relations here again, that is AR is equal to 5 AP and AS is equal to 5 AQ. We will get AP upon AR is equal to 1 upon 5, and this is also 1 upon 5 statement number 2 and statement number 3. Since from 1, 2 and 3, first two ratios we got as 1 upon 5, therefore third ratio will be also 1 upon 5. Since all these three ratios are same, we will get PQ upon RS will be also 1 upon 5. By cross multiplication we will get required result. Take screenshot. Move towards example number 6. Again, there is one trapezium. Now this in this example, quadrilateral ABCD is a trapezium in which AB is parallel to DC. AB is parallel to DC. Diagonals AC and BD intersect in point O. If AB is equal to 20, AB is equal to 20, DC is equal to 6, OB is equal to 15, then find OD. Very simple than previous one, or half of this part is same like previous one. See, in this trapezium, AB is parallel to DC, and these three values are given, and we have to find OD. So see which values are given. AB is given as 20, this side is given as 20, DC is given as 6, this one is given as 6, and OB is given as 15, and we want OD. And means we have to prove sides containing these two triangles, or triangles containing these two sides as similar. And these are nothing but again same. We have to prove these two triangles similar. It is in triangle. I am not going to write all these answers. I will just guide you to write this answer. Pattern will be same. First step is to write proper names of these two triangles, that is in triangle COD and triangle AOB. First step will be like this: triangle COD and triangle AOB, that is in these two triangles. angle COD is congruent to angle AOB. Angle COD is congruent to angle AOB. Reason will be vertically opposite angles. And same again, take this pair or this pair. Angle OCD is congruent to angle OAB. OCD is congruent to angle OAB. Since these two lines are parallel, or it is a trapezium, or AB is parallel to DC, therefore these two angles are alternate angles. That is, angle OCD is congruent to angle OAB. Reason will be alternate angles. Hence, triangle COD is similar to triangle AOB. COD is similar to AOB by AA test. Hence, their corresponding sides will be in proportion. And what are the corresponding sides? For that, I have to write names here. That is triangle COD and triangle COD and AOB. Hence, the corresponding sides are in proportion. That is, CO upon AO is equal to OD upon OB is equal to CD upon AB. Reason will be corresponding sides of similar triangles. Out of these 6 values, only 3 values are given, and we want 4th value. Means we don't want one ratio from these 3 ratios. And which one? We don't want, I think, this one. Means I'll write these 2 ratios again. That is, OD upon OB is equal to CD upon AB. Then putting values, OD we have to find. OB is given as 15. CD is given as, CD means DC, is given as 6, and AB is given as 20. Then by cross multiplication we will get OD into 20 is equal to 15 into 6. Therefore, we will get OD is equal to 15 into 6 by 20. 5 3s are 5 4s are. Therefore, OD is equal to 2 2s are 2 3s are 9 by 2. Therefore, OD is equal to 4.5. OD is equal to 4.5. Means we have got OD here. See once again. First step is to prove these two triangles similar by AA test. Then write their corresponding sides in proportion. Then out of these 3 ratios, take 2 ratios only, since we don't want CO and AO. Since nothing about CO and O is given, we'll take these 2 ratios again. Putting values which are given, we'll get the value which is required, that is OD is equal to 4.5. Take screenshot. Move towards example number 7. One diagram is given and some values are given, or some information is given, that is quadrilateral. ABCD is a parallelogram. Point E is on side BC. Point E is on side BC, means B dash E dash C. Line DE intersects side AB in point T. Then prove that DE into BE is equal to CE into T. Example looks like difficult, but it is very easy. Solution is very easy. See, what is given? Quadrilateral ABCD is a parallelogram. And what is the definition of parallelogram? If opposite sides are parallel, means both pairs, AB is parallel to DC and AD is parallel to BC, both the pairs of opposite sides are parallel, then it is said to be parallelogram. It means AB is parallel to DC, BC is parallel to AD, which is given indirectly in this word. Now we have to prove DE into BE is equal to CE into TE. Now find out the triangles containing all these four sides. First step is to find out triangles containing all these four sides. Means triangle containing BE, DE, C and T. BE, CE, DE and T, and these are these two triangles. Now the first step is to prove these two triangles similar. We'll start with this triangle and then this triangle, that is in triangle. Proper names of these two triangles, that is suppose DCE and triangle, DCE and triangle TBE and triangle TBE. Now in these two triangles, find out common or congruent parts. Nothing about sides is given. Therefore, we have to find congruent angles, and the first angle, pair of angles that we'll get is vertically opposite angles. Names are angle CED. Angle CED is congruent to angle BET. Reason will be vertically opposite angles. Vertically opposite angles. We want one more pair of angles. For that we will use this word, that is parallelogram, that is AB is parallel to DC. AB is parallel to DC, hence AT will be parallel to DC, since AT is extended part of AB. Since AB is parallel to DC, therefore AT will be also parallel to DC, since AT is extended part of AB. Now see diagram like this. This is AT and this is DC. This one is AT, this one is DC, and this is a transversal. This is a transversal. Now since these two lines are parallel and this is a transversal, therefore what is the type of these two angles? What is the type of these two angles? And these are alternate angles, and since these two lines are parallel, therefore alternate angles formed by transversal are congruent, therefore these two angles are congruent. Now find out these two angles in this diagram, that is angle T and angle D. Angle T is congruent to angle D, but the names of these two angles are, for angle D we will take this first, since we have considered this triangle first. Name of this angle is angle CDE is congruent to angle CDE is congruent to angle BTE. Reason alternate angles. Now here we got two pairs of angles as congruent, therefore triangles are similar by AA test. Hence triangle DCE is similar to triangle TBE by angle that is AA test. 8 is. Now since these two triangles are similar, therefore their corresponding sides are in proportion. By using these names I can write corresponding sides in proportion, that is DC upon TB is equal to CE upon BE is equal to D upon T. Reason will be corresponding sides of similar triangles. Now again, out of these three ratios we'll use only two ratios, and we don't want one ratio, therefore we'll not use that one ratio. And which one is that one ratio that we'll not use? That is first one. Since nothing about DC and TB we have to prove, therefore writing these two ratios again, that is CE upon BE is equal to DE upon TE, and by cross multiplication we will get required answer, that is B into D, BE into DE is equal to C into T, CE into T, and that is our target. D into B or B into D, both are same, is equal to C into T. Yes, we have reached up to our target. See once again, there is parallelogram ABCD is given, means opposite sides are parallel, that is AB is parallel to DC, BC is parallel to AD, and we have to prove this relation. Now to prove this relation we have proved these two triangles similar by angle test, that is these two angles are congruent region vertically opposite angles, these two angles are congruent region alternate angles, and these two triangles are congruent by angle test, that is A test. And now since these two triangles are congruent, therefore their corresponding sides are in proportion. Writing these proper names we will get corresponding sides in proportion, reason will be CSST. Out of these three ratios we will take only two ratios containing these four sides, therefore will not use this ratio. Writing these two ratios again, C upon B is equal to D upon T, and by cross multiplication we will get required result. Take screenshot. Example number 8. Though you have taken these screenshots of the solutions, use only if it is necessary, otherwise solve your own. There are two triangles in figure. Each segment AC and BD intersect each other at point P, and one information is given, AP upon CP is equal to BP upon DP. Prove that triangle ABP is similar to triangle CDP. Now see what is given. There are two triangles given, some relation about sides is given, means sides are in proportion which is given, and we have to prove these two triangles similar. Very simple. It is in triangle ABP and triangle CDP. What are congruent parts? That is angle APB and CPD. Angle APB is congruent to angle CPD, region vertically opposite angles. Now we can't use this pair or this pair by using alternate angle test, since the nothing about AB and CD is given, means AB and CD are not parallel. Therefore we can't take these two and these two pairs as alternate angles, though it looks like congruent. Therefore but we will not use that, since nothing about AB and CD is given. But one information is given, that is AP upon CP. AP upon CP means this side upon this side, means side of this triangle upon side of this triangle, is equal to BP upon DP, again side of this triangle upon side of this triangle, means these four sides are in proportion. That is AP upon CP is equal to BP upon DP, reason given. Means sides are in proportion and the included angles are congruent. AP upon CP is equal to BP upon DP. This is given and the included angles are congruent. Hence, triangle ABP is similar to triangle CDP by SAS test of similarity, SAS test. Simple, hence proved. Angle ABP is similar to triangle CDP by SAS test. See once again, in these two triangles, that is in triangle ABP and CDP, in these two triangles, these two angles are congruent. This is only one statement that we have used. This is given and these are only names, and this is last statement. So only one statement that we have used here, that is angle APB is congruent to angle CPD, reason vertically opposite angles, and AP upon CP is equal to BP upon DP, reason is given. Hence triangle ABP is similar to triangle CDP by SAS test, side angle side or side angle side test, that is SAS test. Take screenshot of this, then we'll move towards last example of practice set 1.3, that is example number 9. One diagram is given, example number 9. Diagram is given like this. There is triangle ABC, this point is D, and these two angles are congruent. That is in figure, or in triangle ABC, point D is on side BC, that is B dash D dash C, such that angle BAC is congruent to angle ADC. This is given, and prove that CA square is equal to CB into CD. Again, this is also very simple. We have to prove these two triangles similar, then we will get required result. Find out two triangles that we want containing these two angles and these four sides. That is triangle, this one, and this bigger triangle, that is in triangle ADC, and triangle ADC and bigger triangle, that is C or BAC, angle BAC. In triangle ADC and BAC, angle ADC is congruent to angle BAC, which is given. Angle ADC is congruent to angle BAC, which is given. Angle ADC is congruent to angle BAC, Reason is given. We want one more pair of angles, that is this one. It's common angle. This angle is common for this triangle and this bigger triangle also, but the names are different. For the smaller triangle, name of this angle is angle DCA is congruent to angle. For bigger triangle, name of this angle is ACB. C is same in between these two. Reason is common angle. His triangle ADC is similar to triangle BAC by angle test, that is A test. His the corresponding sides are in proportion, that is AD upon BA is equal to DC upon AC is equal to AC upon BC. Again, out of these three ratios, we will exclude one ratio that we don't want, since nothing about AD and BA is given. Therefore, we will not use this one. Writing these two ratios again, it is DC upon AC is equal to AC upon BC. By cross multiplication, we will get AC into AC, that is AC square. AC into AC, that is AC square is equal to DC into BC. DC into BC. We have reached up to our target, but names are different. AC is nothing but CA. AC and CA are same. Changing these names, CA square is equal to BC means CB into DC means CD. Writing these names like this, but meaning is same. CA square is equal to CB into CD. CA square is equal to CB into CD. Means we have reached up to our target, that is CA square is equal to CB into CD. In this way, we have completed practice set 1.3. Write all these examples your own. Don't use screenshot. If it is necessary, then only use screenshot. Otherwise, solve your own. We stop here. Thank you.